All right, gang, welcome back to another exciting episode of Geometry from Mr. Hawkins' Dining Room. In the opening video, we talked about intersecting lines and circles. And that point of intersection of those two lines can happen in one of three different places in regards to a circle. So again, I could have the intersection of those lines occur on the inside of the circle. That's the first thing we're going to look at today. The intersection could also occur on the outside. That would look something like this. We'll also look at that today. Then we could also have the intersection occur on the circle. That would look something like this. Basically, this third kind is one we've already seen. So again, this is an inscribed angle since the intersection's on the circle, so we know how to do that one. It's just the arc's going to be twice the angle. So what we're going to look at is we're going to look at these two scenarios where you have the intersection on the inside and then the intersection on the outside. So first we're going to focus on the intersection on the inside of the first picture here. It goes like this. It says the measure of an angle formed by two secants or chords that intersect in the interior of a circle is always going to be half the sum of the two arcs that are made, basically. So again, if I'm looking for this angle right here in the picture. So again, the intersection's on the inside of the circle. It's going to be half the sum of the two arcs made. Well, the two arcs made, again, if you look in the forward direction of this angle, I'm making this 100-degree arc. But if you look at the vertical side of this, I also make a 40-degree arc. So again, this angle here is going to equal 1/2 of the sum of the two arcs. So I'd add 100 plus 40, that's 140, take half of it, and that's 70. So that means this is a 70-degree angle. And so the vertical angle would also be 70 degrees. So that's what we're going to use today. And again, the intersection could be on the outside. That's the second picture that I mentioned. Again, this is where the intersection's on the outside right here. When that happens, the angle formed in the exterior of a circle is going to be half again, but now it's going to be of the difference. Now it doesn't matter which way you add things, but it does matter which way you subtract things. You always have to do the big minus the little to get that difference. So you end up with a positive number. So down here, again, if I'm looking for this angle right there, again, two arcs are created by this angle. You have one on the far side of the circle, and you have one on the close side of the circle. So what you can see in here, again, this is the big arc, 110, minus the little arc, 10. The difference of those is 100. Half of 100 is 50. So that means this little angle in there is going to be 50 degrees. That's the way that works when the intersection's on the outside. So down here I have an illustration of both examples, both theorems that we looked at. So again, here the intersection's on the inside. So again, I'm going to take half of the sum of the arcs, but I already know what the angle is. It's 60 degrees. I know the one arc is 20. I just don't know what this big arc is over here. So to figure that out, you basically set it up. So the angle is equal to half of arc plus arc. So in this instance, I know the angle. It's 60 degrees. The two arcs, well, one of them is 20. The other one, I don't know what it is, so I'll just call it x. So then algebraically, I'd probably get rid of the half first by multiplying by 2. And then I have x plus 20. So then I subtract 20. So that means that missing arc has to be 100. And you could check your answer. Okay, if this is 100, and I do 100 plus 20, that's 120. Half of that is 60, so it all works out. So the other example I have here is where the intersection's on the outside. So here I don't know the angle, but I do know the two arcs made. Here's the little arc, and here's the big arc. So again, the angle is going to equal 1/2 of the big arc minus the small arc. So I don't know the angle here, but I do know the arc measurements. So I'm going to take my bigger arc, 260, and subtract out the little arc, 100. And so that's what, 160? And then I take half of that. So that means that angle has to be 80 degrees. So this is an 80-degree angle. So that's when that intersection's on the outside. So again, here's a summary of what we looked at. This is the first thing we looked at. Again, the angle is equal to half of the 2 arcs added. Here's the second example. Again, the angle is equal to half of the big arc minus the little arc. Over here, again, this is where the intersection's on the circle, regardless of what the two sides are doing, whether it's a tangent or whether it's a secant, it's always going to be equal. It's going to behave just like an inscribed angle. So think inscribed. So again, this arc here is made by this angle right there. And so that angle is going to be half of that arc. And that's what this is saying down here. So this asks you to think about the situations of these intersecting lines. It can happen a bunch of ways. The first way we looked at with intersecting lines was basically 2 radii. That is your central angle. So remember, that is the same. Then we had inscribed angles. That's where the intersection was on the circle. So if this is 30, the arc would be double that, or 60. The third scenario is where the intersection's on the inside but not at the center. But if it was at the center, this would still work. But this angle, if I call that x and y, measure of angle 1 would equal 1/2 of x plus y. And then the third scenario, or fourth scenario, where the intersection's on the outside, something like this. Call that angle 1, call this big one x, this one y. So now the measure of angle 1 is equal to 1/2 of the big arc x minus the little arc y. Finally, the last one, which is kind of confusing. It's kind of like an inscribed angle where the intersection is going to be on the circle, but you'll have like a tangent and like a chord. So if I put angle 1 here, so let's suppose this arc here was 100 degrees. So that would be this arc here. So that arc's 100 degrees. That means this angle in here, the measure of angle 1, would be half of it. Because the intersection's on the circle, it behaves just like an inscribed angle, so that measure of angle 1 would have to be 50 degrees. All right, so taking a look at these example problems down here, let's see if we can work our way through these. Again, number 1, I note where the intersection's occurring. The intersection's occurring on the inside of the circle. So identify the 2 arcs here, and I remember that the angle is 1/2 of the sum. So that means x is equal to 1/2 of 88 plus 86. So 88 plus 86 divided by 2, what I do in my calculator, and that's 87. So that's an 87 degree angle. Over here, I'm looking for the angle outside here. Again, note where the intersection's occurring, it's on the outside. So I know that x is going to equal 1/2 of the big arc, which in this case is the 90, minus the little arc, which is 20. 90 minus 20 is 70. Half of that would be equal to 35 degrees. Again, on number 3, except now I have a tangent, but it works the same because the intersection's on the outside. X is going to equal 1/2 of the big arc, 150, minus the little arc, 60. So when I do that, 150 minus 60 is 90. Half of that would be 45. All right, try to put different variations in here for you. So here I have 2 tangents. It's still going to work the same way. Intersection's on the outside. So I know that 60 is going to equal 1/2 of the big arc minus the small arc. I got the small arc, that is x. I got the angle, it's 60. The only thing I'm missing is that big arc. So let me show you how to find that. Again, since they're tangents, I'm using all the arcs of a circle, which are 360 degrees total. Well, this part that I'm interested in is the whole 360 minus whatever x is. So I would call the big arc here 360 minus x. So I end up with this 360 minus x, and then I have to minus x from that. So I have minus x, which is what? Minus 2x. So that 60 is equal to 1/2 of 360 minus 2x. So now I got one variable, I got an equation, so I can go ahead and use algebra to solve this. So I'd probably get rid of the half. Yeah, I'd distribute the half. So it'd be 60 is equal to 180, which is half of 360, and then half of 2x is just x. Then I move the x over here by adding it to make it positive, and then subtract the 60, so I end up with x is equal to 120. So that means that's a 120 degree arc. Over here, again, the intersection's on the outside, and I have the little arc is x, so 38 again. What I know the angle. It's half of the big minus the small. I know what the small arc is, kind of, it's x. So 38 is equal to 1/2 of big minus small, and I know what the small is, x. So again, I'm going to use kind of the same thing that I did on the previous problem, except now I know this 140 degree arc. Well, if this is a 140 degree arc right here, 360 minus 140 would be this arc right here. So 360 minus 140 is what I do first. So that's 0 to 220. So that means this is 220 degree arc. And again, only part of that arc I want is this part right here. So of that 220, I'm only interested in that because that's the big arc. So I would take the whole thing and then subtract out that x. So this would be 220 minus x, which turns out to be my big arc. 220 minus x. So this is the big arc, this is the little arc. Again, two negative x's makes negative 2x. So that's 38 is equal to 1/2 of 220 minus 2x. Probably distribute the half again since they're both even. So that means 38 is equal to 110 minus x. Again, I'd add the x over here to make it positive and subtract that. So I'm going to do 110 minus 38. And that's 72. So let's see how you do that one. Over here, I got this tiny little 6 degree arc right here. It's a tiny little arc. Then the big arc is here. Again, the intersection's on the outside, and it has to be 90 degrees because all 4 of these angles are going to be 90 degrees. So now, since it's on the outside, the angle is equal to 1/2 of the big minus the small. So 90 is equal to 1/2 of the big, which I'm saying is x now, and then I know that small little guy is 6. So now in this scenario, I probably wouldn't multiply by 1/2 here because that's not an even number, so I just multiply by half to get rid of it altogether. That would multiply the 90 times 2, x minus 6, add the 6 to both sides, so that means that big arc is 186 degrees. So over here, I'll try to get through as many as I can here. Here I notice that these intersections are occurring on the outside. And I do have some arc measurements here. This one's 117 degrees. This one's 121. And then this arc here I can find by subtracting these out of 360. So if I do that, 117 plus 121, that's 238, 360 minus that. That arc is 122. All right, let's see what I can do with this now. So let's focus on x first, simply because it's first in the alphabet. That would be the only reason why. Intersection's on the outside. So x is going to equal 1/2 of, again, the intersection's on the outside. The big arc for x is going to be these two added together. So the purple and the green added together, which is 238. So that would be my big arc. Minus the little arc, which is that 122 degree arc right there. So then I do 238 minus 122 divided by 2. So that angle x is going to equal 58. Then I use the same process. We'll go for y next. Again, it's on the outside, so I got to find the big arc for y. Well, the big arc for y would be these two, the pink arc and the purple arc added together, which is 122 plus 17, or 117. And that is 239. And then I subtract out the little arc, which is 121. And then lastly, for z, again, z is on the outside, so I take half the big arc, which is 122 plus 120, 1, and then subtract that from 117. So the answers to the problems are down here at the bottom. I have the completed notes in the folder, so you can check that. Please try the homework. If you have questions, come to office hours or email.